Okay, I want to look at two problems. One finding the average velocity and the other finding the instantaneous velocity. And I'm going to give you an example to help you understand the difference in these two ideas. The average velocity, let's say we were traveling from Dallas to Houston and the trip we found was 200 miles. And we made that trip in 4 hours. Then our average speed, average velocity, would be 50 miles per hour. Now, at every point in that trip, you're not actually traveling at the speed 50 miles per hour. You may have times that you're going, 60 miles an hour, or maybe you're going 30 miles an hour through town. So if you wanted to find the instantaneous velocity, that would mean at any given point in time, you wanted to know what your speed was. So average velocity is figuring out what would that speed be to consistently drive that speed and get there in the 4 hours. Instantaneous velocity is actually your speed at a given point in time. So we want to be able to find that speed at a given point in time. And that's where calculus is going to be helpful. So the first thing we want to do is look at average velocity. Now, to find an average velocity, you're going to look at what the position was at one point in time, position at another point in time, and your velocity is going to be your change. This is your average velocity, will be your change in your position, and we'll use this little symbol delta. It's a little triangle looking thing. Delta S, that's your change in your position over your change in time. Now that's the same thing as in this first problem. We want to find the average velocity between when t is 1 and t is 3. Well, that means we want to find s of 3 minus s of 1. That's the change in the position. Okay, so the position at 3 seconds and the position at 1 second over your change in your time, which will be the 3 second and the 1 second. So all we're doing is we're looking at the difference in the two positions and the difference in the two times. Okay, so now to calculate this, if we're given the formula s of t equal to minus 16t squared plus 96, s of 3 is just going to be 144. So just plug in 3 everywhere the t appears. S of 1, plugging in 1 where all the t's appear, is going to equal to 80. Okay, so delta S, which is S of 3 minus S of 1, is going to be equal to 64. And our change in the time, which is the time at 1 and time at 3, so that change in time is going to be the 3 minus 1, which is 2. So my average velocity is going to be equal to the delta S, which is 64, over the delta t, which is 2. So my average velocity is actually 32 miles per hour. Okay, now that doesn't mean I'm traveling 32 the entire time. Okay, and here we're actually talking about throwing a rock up and what is the speed of the rock. So we're looking at the velocity of the rock, and of course when you throw it up it's a certain speed, and as it goes up, gravity is going to cause it to come to a stop for just an instant up there at the top, and then it's going to be coming back down and building up speed as it goes down. Okay, so average velocity, change in the position over the change in time. So now in the second one, I want to find the average velocity between t equal 1 and t equal 2. So the average velocity then will be my change in the velocity in position, so that's s of 2 minus s of 1 over my change in time, which is 2 minus 1. Okay, now s of 2, if I put 2 into the function, I get 128. S of 1 we already found to be 80. So now our 2 minus 1 is just going to be 1. So we're going to end up with 48 over 1, or just 48 miles per hour. It's actually, it's not miles per hour here. We're talking about our distance is given as feet. Okay, so they're giving it to you as feet, and then seconds is the time. So this is 48 feet per second. Okay, so that's the average velocity if we're just looking at the 2 points where t is 1 and t is 2. Okay, so the definition of an average velocity is the slope of the line that's joining the points on the graph of that position function. Okay, so we found this point here. This was the point when t was equal to 1. That was the point 180, given by the function that we were given. And now at t equal 3, our point up here was just the point 3, 144. The slope of that line is the change in y's, which the y values here are representing that position. So the change in y's, which here's the notation you could use, I don't know if you use this back in algebra or not, delta y, that's your change in your y values over your change in your x's. So that's like y2 minus y1 over x2 minus x1. Okay, that's your average velocity, and that is just the slope of that line passing through those 2 points. Okay, and on the second one, we had t equal to 1, and the y value at that point was 80, which was our position. So 1, 80, and that's the height above the ground that problem gave us. And then t equal to 3, t equal to 2 in this second problem, t equal to 2, and we had that this point was the point 2, 128. So if you just wanted to find the slope of the line passing through those 2 points, that's going to give you your average velocity. So the average velocity is the change in your y's, 128 minus 80, over their change in x's, which is time in this case, so over 1. Okay, so now instantaneous velocity. We know how to get the slope of that line passing through those 2 points as long as we have the 2 points. Instantaneous velocity is just giving us just one specific time. How do I find what that speed is at one particular time? Now the way we're going to do that, we know how to get the speed if we have 2 different times, and get the average over those 2 times. So what we're going to do to get the speed at one given point, which is your instantaneous velocity, is to look at different intervals. So if I were trying to find the speed at t equal to 1, so here's my y-axis here. Let's say t equal to 1. I want to find what that speed is at that given point in time. Well, what I'm going to do is I'm going to first start with an interval. I'm going to maybe find the average velocity from 1 to 3. Okay? And we got that average velocity was 32. And then the average velocity from 1 to 2. We got that average velocity was 48. Then we're going to keep reducing this interval. Always keep that first point the same. It could be the second point if you want to work on, going from 0 to 1 and then half to 1. But you're going to fix that point and let the second one constantly be getting closer to the first point. So now I would pick something closer to 1 than 2 was, so let's say 1.5. And then I would maybe get something even closer, 1 and 1.25. Maybe 1 and 1.1. So I'm going to keep decreasing the width, the length of that time interval, and I keep getting the average velocity over that interval each time. So here I'm down to getting the average velocity between 1 and 1.1 seconds. That average is going to be very close to what the velocity is at 1. So what you're going to do is take all these intervals, keep decreasing the width of them until you get closer and closer to that value t equal 1. So as t1, you're going to look at intervals, average velocities over these intervals, t0 to t1, that decrease in length. Okay? As t1 gets closer and closer to t0, those average velocities will give you a unique number that's called the instantaneous velocity. So your average velocity will be what these average velocities are going to be getting closer and closer to as that width of that interval decreases. And that single number is called a limit, because we're never actually going to reach that number, but if these values are getting closer and closer to a certain number, then that limit, that value they're getting close to, we call the instantaneous velocity. So instantaneous velocity is actually a limit of those average velocities as the interval gets shorter and shorter. Okay, so now I want to actually estimate what the instantaneous velocity is for the rock at t equal 1. Well, we already found that on the interval from 1 to 2 here, the average velocity was 48. It was 48. Okay, now keep using intervals. Now we're going to use 1 to 1.5. And we're going to find that average velocity. So to calculate this, the average velocity over this interval would be s of 1.5. So the position at 1.5 seconds minus the position at 1 over 1.5 minus 1. Okay? And when you evaluate the function at 1.5 and evaluate the function at 1, subtract and then divide by 1/2, you're going to end up with 56 feet per second. Do the same thing for the interval 1.1. So this would be finding s of 1.1 minus s of 1 over 1.1 minus 1. So when you plug in 1.1 into that original function, get that value, subtract s of 1, get that and divide it by 0.1, which is the 1.1 minus the 1, this comes out to be 62.4. Okay? So now look at what these values are doing. As this interval gets smaller and smaller, that second number is getting closer and closer to 1, these values, here we've got 63.84, 63.984, 63.9984. What are these average velocities getting closer and closer to? They're getting closer and closer to the number 64, and this interval is getting closer and closer to just the single point where t was equal to 1. That's called our instantaneous velocity. So our instantaneous velocity here is going to be 64. That's the limit of the average velocities as that interval decreases, the length of it decreases.